Okay guys, let me draw your attention up here real quick. I just want to unpack something from the Socrative exercise that I think a few of us, when I look at the results, might have gotten wrong. And it pokes up a few times here in some other problems. So this was, I think, question 4. Obviously you can see the correct answer. But this was the one where we had 1/4 mole of glucose was added, and we saw a freezing point depression. Then we added the same amount of lithium chloride, 1/4 mole of lithium chloride, to the same amount of water, okay? And you had to figure out what the new freezing point depression was. So with glucose, it was 1.15. Why is it 2.3 when you use lithium chloride? What's the key feature that lithium chloride is bringing to the table that glucose did not? What's the key distinction there? Having done the Moodle exercise, we should be getting a lot more input on this one. So what's the key distinction? Key distinction. It's ionic. What does that mean? It's ionic, Anthony.
It means that it separates into 2 separate ions.
In this case, lithium chloride, right, dissociates into 2 separate ions, okay? Can somebody think of an ionic compound where the factor of the freezing point or boiling point change would be a factor of 3? Where we would get a factor of 3 in the delta TV or the delta T. What would be an example where we would have a factor of 3? Now you have to get creative. You got to come up with something on your own. A factor of 3. Kimmy? MgCl2. Good. How about, can everybody write down in their notes, how about one that would give you a factor of 4? Can you come up with an ionic compound that would give you a factor of 4? A factor of 4.
I can do a factor of 5.
A factor of 5?
Well, I mean, okay,
How about a factor of 20?
Okay, rust does not dissolve in water.
Oh, this should be a contest. How high can you go?
6. Okay, rust does not dissolve in water, but it would.
If it would. Who's got a factor of 4? Somebody got a factor of 4 yet? Let's get a couple of more that have a factor of 4. Factor of 4. Pablo, you got one? What's your factor of 4?
Magnesium oxide.
Magnesium oxide. Mg, what's the formula for magnesium oxide?
That's 2.
Yeah, it's MgO, right? So that would give you a factor of, how many ions are here? There's 2, right? Plus 2, minus 2, right? So that would give us a factor of 2. Ryan, do you have a factor of 4?
I believe AlF3 is that's ionic. Because AlCl3 is not, but F is more electronegative, so I hope that's ionic.
AlF3. Yeah, that would give us a factor of 4. Anthony?
H3PO4.
H3PO4. Now, that theoretically could, but it gets a little bit more subtle than that, okay? What is H3PO4 not going to fully do as it tries to continue to dissociate? H2PO4 minus, is that a strong acid? No, it's not, right? So each consecutive H doesn't get fully liberated. So it's a good candidate, but because the subsequent acids aren't fully strong, you don't get the full liberation. Can anybody else think of a factor of 4? These are tricky because you've got to come up with it on your own. A factor of 4. Kimmy's now looking at her periodic table, which is probably a pretty good idea. A factor of 4. A factor of 4. Pablo, I feel like I should go back to you so you can.
NH3.
What's that?
NH3.
NH3 is a molecular compound, right? That's only going to be a factor of 1.
If you replace the H with like a metal, then it would...
Brianna, you get a factor of 4. Maybe. Let's see. Yeah. This was not a factor of 4. Okay, Anthony, you got one?
Wooden complexes work for this.
Okay.
Like AlNH4 plus to the 6th.
Okay, yes, that
Four.
has a chance of working. Actually, sorry, 3. Yeah, that has a chance of working, okay? These are hard to kind of create on your own. The important thing is just to be cognizant that when we have ionic compounds, things are going to dissociate. Now, for homework, we don't have any videos I need to show you.